Hi, this is Aaron Jerome again from Jerome Electronics. It's time to talk about another topic. The topic, I should probably mention, this is a great image that's relevant to what we're going to talk about. And it was so good, I thought maybe I better give Bryce R. and ZBrush Central some credit for it. Great image. Okay, so we're going to be talking about 2's complement today, which is really binary subtraction. And in the previous video, we learned all of the things we need to learn, the foundation for binary addition. So that got us ready for binary subtraction. Addition, fairly simple as long as you memorize these 4 combinations that are being added, and we always add in a stack of 3, and the answer is always 2 digits. The one on the right is the sum, the one on the left is the carryover. If you can remember that, you pretty much got addition down. Now, to add numbers, a computer will compare the ones and zeros and then respond to every one of these combinations. That's how it works, comparing and responding. That's exactly what logic gates do, and that's what we do in this course. Is we connect logic gates to make greater and greater artificial intelligence. Okay, so let's talk about binary subtraction. Computers can perform tasks really fast. They can actually perform tasks in terms of nanoseconds, and nanoseconds are really fast. 1 nanosecond is a billionth of a second. One task in a billionth of a second. So they can add very fast. They're known for adding fast, and if you can add fast, of course, that is multiplication. But subtracting, if they could subtract, back in the day before they could subtract, they could also do that fast too, if we can figure out how to make them do it. And fast subtraction is also known as division. So once we have addition down and subtraction down, we also have multiplication and division down. Okay, so how did they figure it out? Well, scientists, I don't know. I always tell my students they stare at a wall with a question in their mind. And so this scientist staring at a wall, how could subtraction be automated? That's his question. He's pondering that question, staring at a wall for a very long time. And pretty soon he has an epiphany. I bet you'd like to see what an epiphany looks like. An insight. There it is. He had an insight. Are addition and subtraction actually opposites? It seems if you think about life, it seems that there's an opposite for just about everything. I found these fun little opposites slides at Board Panda, Silly Puns Opposites, Hands Off My Dinosaur. So, what's the opposite of breakfast? Break slow. Right, you getting the idea. Radioactive, what's the opposite of radioactive? My students get this so fast. Radio lazy. They seem to be pretty sharp on these things. What's the opposite of pasteurized? Well, futurized, of course. What is the opposite of a dumpling? A smartling. What's the opposite of fireworks? Waterworks. And my last one, favorite one. Have you ever had a smoothie before? What's the opposite of a smoothie? A roughie. If anybody offers you a roughie, don't take it. All right, so anyway, staring at a wall, thinking, oh, wait a second. Opposites. Maybe, this scientist had this insight, maybe if you flip the negative value to its positive complement, then maybe you can just add. And that is the big insight to where we can actually subtract with computers. It is so similar to adding. All you have to do is flip the negative value to its positive complement and then add. What does that mean? Well, here's some ideas. Everything has an opposite, including numbers. Binary numbers have opposites. Of course, there's only 2 numbers, so the opposite of 1 has to be 0, and vice versa. And instead of trying to subtract, convert the number to its opposite, also known as its complement, and then add the numbers together. Okay, so that's what we're going to focus on right now, how that is actually done. This subtraction trick is called 2's complement. And let's define the phrase 2's complement. Complement means clever opposite trick. Complement means clever opposite trick. 2's means that the trick has 2 parts to it. So what we're going to do is we're going to get some random byte of binary bits. There it is. And we are going to say, okay, if this were a negative number, what would its positive complement be? And the 2 parts are, first, flip all the numbers to their opposites. That's pretty simple. 0 becomes a 1, 0 becomes a 1, 1 becomes a 0, 0 becomes a 1, 0, 0, 1, 0. So now I flipped this number to its opposite, but we're not quite there yet because part 2, we add 1 to the number. So that's what we're doing now. We're going to add 1 to this number. 1 plus 1, remember it's a stack of 3. The top one is a 0. 0 plus 1 plus 1. 1 plus 1 is 2, right? And in binary, that's a 1, 0. So the 0 is the answer, the sum, and the 1 on the left is the carryover. And now we're going to add those as well. 1 plus 1 is 2. The carryover goes on the top of the next one. So 1 plus 0, well, that's just a 1, also known as 0, 1. And the 0 is the carryover. 1 plus 0, that's 0, 1, and the 0 is the carryover. 0 plus 0, that's 0, 0 is the carryover. 0 plus 0, that's 0, the 0 is the carryover. 0 plus 1, that's 1 with a 0, the carryover. And 0 plus 0, that's a 0 with the carryover, but there's no more numbers to stack up on top of, so we'll just drop that 0. Okay, that's 2's complement. That is how you 2's complement to find the opposite or complement of a number. Okay. This is the complement of this original value. But what I've just showed you really is the slow way to do this. So let's learn the fast way to 2's complement. Okay. Do this instead. Approaching from the right side, we're going to keep any zeros we find. So we're going to keep that 0. We're going to keep that 0. Next, we're going to also keep the first 1. Keep it. Then we're going to flip the rest. 0 becomes a 1, 0, 0, 1, 0. Notice that the results are exactly the same. So if you remember, approach from the right, keep all the zeros you run into, keep the first 1, then flip the rest. That is the fast method of applying 2's complement. Okay? All right. 2's complement, there's a couple rules we need to talk about as well. Guidelines, probably more like. This is Grumpy Gus. Grumpy Gus is a negative goat. We should 2's complement negative things. So we're going to 2's complement Grumpy Gus to make Grumpy Gus a positive goat. But the point here I'm trying to make is only 2's complement negative things. More specifically, only 2's complement negative numbers. Okay? So 2's complementing Grumpy Gus. Now we have Happy Gus. Happy Gus is the complement of Grumpy Gus, and Happy Gus is a positive goat. Most importantly, do not 2's complement any positive things. Okay? So only 2's complement negative things, but remember, the negatives could be in the questions as well as in the answers. So if anything in the question is a negative number, we're going to 2's complement it. If anything in the answer is negative, we're going to 2's complement that as well. And so here's an example, okay? What we're going to do, I'm going to start out in decimal, and so you can see it actually works. 9 minus 5 should be a 4. So now we're going to recreate 9, but in binary. That would be 8 plus 1. And then we're going to recreate 5 in binary. That's a 0, 1, 0, 1. And then we are going to recreate the 9 again, but this time we're going to 2's complement the negative number, the 5. Okay, so we're starting from the right, and we're going to keep all of the zeros. There aren't any. And then we're going to keep the first one we come across, and put that in our new equation. Then we're going to go to the next number, and that happens to be, well, the rest we flip. Remember, come for the right, keep all the zeros. There weren't any. Keep the first one and flip everything else. So now we're going to flip everything else. And now, the cool thing about 2's complement is we can add these two new numbers, and the answer will be 4. Seems strange, but true. So I'm going to put this boundary in here. What the deal is with this boundary is we're going to add until we have a carryover that crosses that boundary. When the carryover crosses that boundary, that carryover is the sign. It represents the sign for the computer. So we're going to add until we have either a 1 or a 0 crosses that boundary. If it's a 1, the result is going to be a positive number. If it's a 0, the result's going to be a negative number. Okay, 1 plus 1, 0 with a 1 carryover. 1 plus 0 plus 1, 0 with a 1 carryover. 1 plus 0 plus 0 is 1 with a 0 carryover, and 0 plus 1 happens to be a 0 with a 1 carryover. And that 1 carryover, well, it jumped over to the other side of the barrier, and so that is the sign of this equation. So 1s are positive, 0s are negative, so now we've got a positive number. I'm going to drop the leading 0 and acknowledge that 100 is indeed a binary 4. Okay, so that's example A. Let's mix it up a little bit. Here is example B. This time we're going to take 5, but we're going to subtract 9. That means we're going to get a negative number as a result. So we can see how the negative carryover that crosses the boundary, how does that work? Okay, so a 5, 0, 1, 0, 1, and a 9, that's a negative 1, 0, 0, 1 in binary. Now we're going to keep the number 5 binary, but we're going to 2's complement the 9. So we're going to start from the right and move to the left and keep all the zeros that we find along the way, there aren't any, until we get to the first one. Once we get to the first one, we're also going to keep that, and then we're going to flip everything else after that. So the zeros become 1s and the 1 becomes a 0. Now we should be able to add these two numbers and get negative 4. Okay, so here we go. We better put the boundary on there so we can see what crosses. By the way, the rule for that boundary is just always put it at the end of the longest original number that we're going to be working with. Okay, and so there's the boundary. Anything that crosses that will be the sign. By the way, this is a good point to also mention that if we drop those two leading zeros and put the boundary next to the 1s, it will still work. Okay, but we're going to go this way. Here we go. 1 plus 1 is 2, 0 with a 1 carryover. And now we got 1 plus 0 plus 1, which is 2. That's a 0 with a 1 carryover. And then 1 plus 1 plus 1 is 3. That is a 1 with a 1 carryover. And then 1 plus 0 is 1 with a 0 carryover. Now we've had a 0 cross the boundary line. That 0 implies that our answer is negative. If you remember the special rules, anything that's negative has to be 2's complemented. So students or anybody watching this video, if you see 1100, you know that's an 8 plus a 4, that's a 12. That's not a negative 4 like on the other side. It won't be a negative 4 until we 2's complement the number. So that's what we're going to do next. Okay, starting from the right, we're going to keep all of the zeros until we get to the first one, and then we're going to keep that 1, and then from then on, we're going to flip those numbers. Okay? Now, we ran out of numbers. I'm going to drop the leading 0, and now you can see that negative 100 in binary is the same thing as negative 4 in decimal. Works like magic, really cool. What about this kind of a problem? Negative 2 minus a minus 3. Looking at that, your intuition is probably correct. Double negatives make a positive. And the plus in a decimal number is often implied, which means if a sign is not shown, or if an operator is not shown, then it's implied to be a positive number. Okay. Now, minus 2 plus 3 is definitely going to be a 1. So when we go through this number in binary, we're going to find that a 0, 0, 1, 0, 0, that is a 2, but it's a negative 2. Now below that is a 3, that will be 1, 1, 0, 0, and so now the top number is the one we're going to 2's complement. Okay, so just keeping the bottom number as it is. Top number, we're coming from the right and keeping all the zeros that we find, and until we get to the first one, and then we're also keeping that. And after that, we're just flipping all of the remaining numbers. Now we can add these two numbers, and when we do, we should get the answer 1. So, we got to add the boundary, anything that crosses the boundary, right? And 0 plus 1 is 1 with a 0 carryover. 1 plus 1 is 2, so the 1 is a carryover. 1 plus 1 is a 2 with a 1 carryover. 1 plus 1 is 2. And of course, the last carryover that crosses the boundary is a 1. So that means this is going to be a positive answer. We don't need to 2's complement it, but I will drop those leading zeros so that we can see that the answers are indeed the same. Okay? So now you've seen 3 good examples of how to 2's complement a number, or how a computer subtracts numbers. And after showing this video in my classroom, I actually give students a test, a 2's complement test. It's a computerized test that's automatically graded. And when you take the test, you are supposed to not only give the answer, but drop any leading zeros and put the sign in front of the answer. Okay, whether it's a positive or a negative, whether it's a plus or a minus. Okay, so here's some things we want to remember as we take the test. First of all, 2's complement negative numbers to find the opposite of the negative, and do that whether it's in the actual question or in the answer. Add the numbers together to get the solution. If the results are negative, you 2's complement them to get the right solution. Then convert to decimal if you feel like you need to prove your answer. This reminds me of a point I need to make, though. A lot of students think, well, what I will do for the test is I will convert the binary number to a decimal number, do the math, and convert it back. Why would I discourage doing this? It is a possible way to do things, but what we're learning is how a computer does it. And so you need to demonstrate that you can, that you know how a computer subtracts. And there are test questions that involve that later that don't involve converting it to decimal and then back to binary. Another reason is both my tests and the end of level tests will not give you enough time to check your answer if it's a timed test. Learning the 2's complement method is actually much faster than trying to convert it to decimal and finding the answer and then converting it back. So just be aware of those things. The overall point I'm trying to make, though, is that we're really learning how computers work. And so you don't get in the rut of taking the long way around. So you can convert to decimal to prove your answer. And I tell my students, if you want me to troubleshoot how you took a wrong turn, maybe when you got a test question wrong, if you show your work on your scratch paper, then I can point to the path where you might have taken a wrong turn. Okay, here is a test style question example A. Okay, so right now, pause the video, see if you can figure it out, and then start the video again. Okay, here's how I get the answer. First of all, I'm going to put up the barrier, so the number that crosses that will remind me that this is either going to be a positive or a negative result. Then looks like I'm going to have to 2's complement that bottom number. Coming from the right, I'm going to keep all the zeros, there aren't any, and I'm going to keep the first one, but then I'm going to flip all of the rest of the numbers, and it is 2's complemented. Next thing I'm going to add 1 plus, and I'm going to put the plus there because if I 2's complemented, I am now ready to add the two numbers. Okay, so there we go. 1 plus 1 is 1, 0, or 2 in binary, carry the 1. 1 plus 1 is 2 in binary, carry the 1. 1 plus 1 is 2 in binary, carry the 1. 1 plus 1 plus 1 is 3, but in binary, that's a 1, 1, carry the 1. 1 plus 1 is 3, carry the 1. 1 plus 1 is 2, and that's a 1, 0 in binary. And of course, that last number, that last carryover crossed the boundary. It's a 1. That means this is a positive answer. We don't have to 2's complemented to get the answer. That is the answer. I might drop the leading 0, but that is the answer. Okay, here is another example. Right now you want to pause the video and see if you can get this answer before I show you how it's done. Then turn the video back on. Okay, here's how you get the answer to this. First of all, I'm going to put the barrier up, so any number that crosses that barrier will tell us the sign. Next, I am going to approach from the right, keeping all the zeros that I find. There aren't any. And then I'm going to keep the first one that I find as well. And once I have kept that first one, I can just flip the rest of the numbers. And I'm going to flip the negative sign to a positive sign, indicating that I am ready to add these two numbers. Okay, 1 plus 1 is 0 with a 1 carryover. 1 plus 1 plus 1 is 1 with a 1 carryover. That's a binary 3. 1 plus 1 is 0 with a 1 carryover. 1 plus 1 plus 1 is a 3. That's a 1 with a 1 carryover in binary. 1 plus 0 is 1 with a 0 carryover. And 0 plus 1 plus 0 is 1 with a 0 carryover. It was a 0 that crossed that boundary. That means this will be a negative number. Remember, you have to 2's complement all negative numbers to make them accurate. Computers know how to do this. So I'm going to come from the right, and I'm going to keep all of the zeros I find. There it is right there. And then I'm going to also, when I get to the first one, I'm going to keep that. And then I'm going to flip all of the rest. And now I don't change the sign, but all I did was make it a different color. And then I can drop the leading zeros, and my answer is binary 4 plus 2. That's a binary 6. That should be the answer. Okay, we're ready for the test. This has been a video about 2's complement and binary subtraction from Jerome Electronics. Thanks for watching. Talk to you next time. Bye-bye.